I'm Jason Lee, and this is my product called Depo. Depo is a parcel delivery solution for the home. It's designed to remove the problem of not being at home when parcel deliveries arrive. So it works by having three separate elements, that is the parcel box itself, which securely stores the parcels outdoors and prevents theft. We've also got the electronics hub, which belongs to the homeowner as well, and that interacts with the homeowner's internet supply and effectively controls the electronics of the homeowner's parcel box. You've also got the barcode reader, which resides with the courier, and the courier would use this upon delivering to scan the parcel and literally take it to the parcel box that the parcel is expected to be delivered to and dock it. Upon docking it, it wakes up the device and all the electronics are up and running. The barcode itself is then transferred by infrared wirelessly into a recipient's parcel box. The parcel box then transfers that via the electronics hub to the internet, where it verifies whether it's expecting that barcode to be, and hence the parcel. In terms of my product development, I think I'm at a good stage at which I can take this product from prototyping, from what I've got here, which fully demonstrates the scenarios for given stakeholders. I think I could take this to a manufacturer and they would be able to build upon it to make sure it can be mass manufactured. Out of all the time I've spent on this project, I think I've probably spent about 65% of my time doing the electronics and getting to a point that it is now where I can demonstrate the scenarios that I wanted to. But I think the fact that electronics took so much time probably had a bit of an impact on the other elements, say aesthetics, which I could have spent a bit more time on. In terms of whether this is fully developed, I think there needs to be more development done in the other areas like materials analysis and styling. In terms of the electronics, I had to develop all the components on a breadboard, and using the breadboard I was able to wire up test points where I can plug that into a computer. From a computer I was able to analyze what's actually really going on between the components. In particular, the wireless communication needs serial data, and to develop the serial data and to see what's actually being transferred in terms of like text, we were able to read that using software like Hyperterminal on a computer. I think the biggest problem I had during the electronics development was when I started, I tried to take apart off-the-shelf products and trying to decode those for my prototype. But having tried to decode it and having to decode other people's code and software and their hardware, it proved difficult to do that. I decided that I'd actually make my own and make my own from scratch. But having done that, it meant that I had to spend more time on the electronics, which I couldn't, which I probably shouldn't have, because I had a detrimental effect on other areas. When I was thinking of final year project ideas, I really like the idea of doing something electronic, because with electronics you can see things happening and you effectively make it happen and you can see what's going on. So clearly I've got a lot of electronics here, but maybe it was a bit more of a challenge now what I would have imagined. There could have been easier ways of doing the electronics, like using designer-related programmers, rather than pick, for example, straight from microchips or microcontrollers. So if I was going back to the start of the year, I probably would have chosen a simpler electronic product. If I couldn't do that and I wanted to really do this, I think I could have demonstrated only some of the functionality rather than trying to achieve more than what I wanted. Do more of the electronics, you fully demonstrate what's actually going on, and you can almost say to people, like, this is literally it, and you can take this and it's more believable than if you just simulated something. So as a final year project, I wanted it to be able to demonstrate all my abilities, from materials analysis to aesthetics to electronics and mechanics. And what we've got here is a more fully functional electronics than what I could have done, which was purely to simulate a few of the effects of what's going on. So by having all the electronics effectively working, I think I literally could take this and present it in front of clients or present it in front of investors and say to them, here's my concept. And it's probably more believable that I've done all this than simulating. Before university, I think the only electronics I did was physics lessons or the odd electronic or D&T lessons where you would get schematics given to you, you'd be given the components given to you, you'd be told solder this to that. Coming to university, we've been able to design electronics and make our own prototypes. So what we've got here is barcode reader here, electronics over here, and parcel box. The parcel box is what stores the parcels itself and securely stores them until the courier says to open it or the consumer says to open it. You've got the electronics hub here, which is the interface between the parcel box and the internet. And this effectively connects the parcel box system at the homeowner's home and connects to the Wi-Fi online. We've got the barcode reader here, which belongs to the courier. Here we've got the electronics prototype of the barcode reader. So this is like a 2.8 times bigger than the actual aesthetic model here. And the last part is the consumer has the ability to unlock the parcel box at their house by using the mobile phone app. If I just show you that basic functionality here, so when I hit the unlock button, it effectively unlocks the parcel box to allow the consumer to open. And upon opening it, the parcel box has the ability to unlock itself after 2 seconds.